Hey, what's up, guys? So let's solve this 1A19 number of different subsequence GCDs. So this problem is a very tricky. So give numbers and a positive integer, and you know the GCD, right? Greatest common divisor. So for example, greatest common divisor for 16 is a 2. Okay, and the subsequence, you take any subsequences that you don't remove or change the order, right? But this problem is stupid, right? Because you want to compute in the GCD. So GCD of the subsequence is independent of orders. So you need to return a number of different GCDs among all non-empty. For example, 6, 10, 3, 6, 10, 3, right? So in this case, you have total, in this case, you have 6 numbers. Sorry, 3 numbers. So you get 2 to the 3 subsets minus the empty one. So in general, you should have 7 GCDs. Okay, and then you count. Oh, there are 5 of them, right? So total will return 5. Okay, for this one, you get 30. You should get you may get 31 of GCDs, but you only get 7. And this is a very technical, very not very easy task to see what is the possible. What is the case that you get all? What is the case that you can get as large as different GCDs? But this is a different problem. Okay, so the key to do this is that let me just write down the idea. So idea is that let's say you define the m to be the maximum of the array. So let's define maximum to nums, and then you know the possible answer, right? The possible answer must the sort of all the possible answer must lies in 1 to 2 to 3 up to m. Okay, because if m is because the GCD, right, the GCD of A1, A2 up to AN is less or equal to minimum of A1, A2, AN. So the largest GCD you can have is just this maximum. Okay. So now all you need to do is check one by one. You check. So now just check one by one. Okay. But the problem is that if you do this, then the complexity will be m times. Let's say the length. Let's say this length is n. So let's define n to be length of nums. Right. So for each m, you need to check n numbers and do the n division. Okay. So it's m times n. And if you see maybe it's 10 to the 5 and the 2 to the, so this is 10 to the 10. Right, so it's 10 to the 10, and the 10 to the 10 is not allowed. It's not allowed to get your answer, right? So the tricky part is that check one by one case, you don't need to do this, right? You can define a set, which defined to be sets of the numbers, and then you just check that let's say you choose your possible to be p, then you just check that whether the multiple of p. So you just check whether the multiple of p belongs to this set S. And the things you already do this, right? So you just take the O1 time to check where P is multiple. And let's say you take all the multiple of P. Let's say this is M1, M2, up to MK. And you can compute whether GCD of M1, M2, MK is same as P. If it's the same as P, then you get an answer. Okay, you get a 1 of answer, which is P. So you just define your answer to be 0. And whenever you see the GCD of this is P, you just add 1. You just add 1. And then finally, you just return answer. Okay. So what is the complexity of this code? Right. So you get m times the number of multiples of P less than number of multiple less than m. Okay. So for each I should say for each P, you need to count the number of multiple or less than m. So let's say you choose P to be 1, which is m, less than, and which you choose m is 2, which I think, I mean, so there are, if P is 2, at most m divided by 2, right? Or P is 3. Okay, so you get m squared, and then I think this is 1 plus half plus m, right? So this is a harmonic sequence. So it should be, right, should be let's see, So it should be m squared log m, right? So this is I think possible, hopefully. Okay. But this is the list, right? But this is also bounded by the number of lengths n. So this guy, so this is so large, but I mean, these guys are bounded by the number of odd n. So this guy is m most n, right? So this is possible. The possible that you can do this. So basically, define m answer and the nums as a set, and for I in range 1 m plus 1, you define the g to be 0. This is just keep updating GCD, right? So for j in range 1 m divided by I plus 1, this is all the possible case that if g times I in nums, which means that the multiple of I exists, okay? And then you update the GCD. Finally, if the GCD equals to I, that means you find an answer, you just update. This is the possible way that you can solve this problem without, so you can still pass. But the detail of the complex analysis may be a little bit difficult, but yeah, okay. See you guys next videos.